Okay, so we continue with chapter 11. Okay, yaitu okay 11.2 about okay strain energy. Okay, so as I told you before, okay, for information, okay, in chapter 5 you learn about potential energy stored in the spring, right? Okay, yaitu that one is actually okay elastic potential energy stored in the spring. So in this chapter, what we talk about is actually wire, right? Okay, so for information, if we do some work on the wire, okay, if you do some work, so the work done that you do actually will be converted okay into elastic potential energy as well. Okay, but in this chapter, this name we don't call this. Okay, we call this name as what we say is actually strain energy. Okay, we say about this. Okay, so in chapter 5, the graph that is important that you learn is actually force versus displacement graph, right? Okay, but in this chapter we don't use this symbol x. What symbol do we use? We use the symbol elongation. Okay, so for example, okay, like the graph that we learned yesterday, we learned two graphs, right? Okay, the first graph that Madam introduced yesterday is actually graph stress versus strain, right? The graph that I introduced, okay, so for ductile material, okay, the shape for the graph something like this, right? Okay, but now I just focus on this part, means from point O to point limit of proportionality. Okay, means from point O to A actually is obey Hooke's law. I just focus on here. I just focus on the straight line there. Okay, so for the part straight line, so I have this. So as I told you, okay, before, stress because it's proportional to air force, strain because it's proportional to elongation. So the graph for force versus elongation, the shape for the graph will be same as graph for stress versus strain. Okay, jadi ini graph yang kita ada. And this graph actually similar to what you learned before, that is chapter 5. And how you're going to find work done. How you're going to find work done? We always find the work done by finding area under the graph, right? So area under this graph, I found that it's a triangle. So formula for the triangle is actually half times with base. Base is actually, this one is the x-axis, that is elongation. We always use half times with base times with height. Our height is actually this one. So half Fe actually same as the equation for the strain energy. Means that the formula for the strain energy, I can use half Fe. Okay, and according to Hooke's law, okay, according to Hooke's law, okay, we have this important equation, right? According to Hooke's law, F actually equals to Kx, right? Okay, means restoring force always proportional to the displacement. Okay, so from the Hooke's law, I found that F also equals to Kx, or as I told you before in this chapter, X instead of X we use E, right? Okay, jadi di sini kita guna E dekat sini. So what is the other equation for strain energy? I have this. Alright. Jadi dari sini kita pun boleh, okay, derive another equation, you see, Okay, derive another equation for, what is the equation of that? About this. So we start with strain energy actually equals to half Fe. Okay, so if F, I want to relate with stress, for my information, stress is actually equals to F over A, right? Okay, so kalau saya jadikan F sebagai subject matter, means divide by A, dia akan jadi apa? Darab A. Maksudnya F sebenarnya sama dengan stress darab dengan A. So I substitute in here, dia sama juga dengan stress darab dengan apa? A. And for the term elongation, if I want to relate with, okay, other terms, saya kena dapati, okay, strain, saya akan guna formula strain. Strain is actually equals to elongation divided by L naught, right? Okay, and if you rearrange, what do you get? Okay, pindahkan L naught ke kiri, so what do you get? L naught times with strain. Okay, so this part, ini saya akan ganti dalam sini. Okay, ini saya akan ganti dalam sini. Jadi apa yang saya dapat? E kalau saya ganti dengan L naught darab dengan strain. So this one is the formula that I get. Okay, and di sini kalau area darab dengan ni, so what do you get? Okay, so for example, kalau cross sectional area yang saya ada, okay, circle for example, okay, contohnya ini cross sectional area, ini area, kalau darab dengan panjang, okay, apa yang saya dapat? I will get volume, right? Okay, I can get for example here volume of a cylinder. Maksudnya kalau area darab dengan length, what do I get? I will get volume. Kalau saya pindahkan volume ke kiri, okay, so apa lagi yang saya dapat? I will get something interesting here, iaitu, okay, kalau strain energy here masih sama, volume kalau pindah ke kiri, what do I get? I will get strain energy per volume sama juga dengan half stress strain. So class for information, this one another formula that you should learn. Okay, formula bagi strain energy per volume adalah half stress strain. Okay, jadi you kena belajar ini, ya. Okay, so now see, so after we learn this formula, okay, we talk about the graph. Okay, you see, and from the graph here I found that, okay, if I find area under this graph, what do I get? I will get strain energy, right? But what if I find gradient? If I find gradient from this graph, what do I get? Okay, kalau saya kira gradient, apa maksud dia? Saya akan guna, okay, delta F divide by delta E. F divide by E, what do I get? F divide by E, okay, you see, yeah? If you rearrange this formula so that K sebagai subject matter, what do you get here? Force divided by E. Okay, so force divided by E, what do you get for information? Means gradient for this graph, you get a spring constant here. That is value for K. Okay, this one actually shows stiffness for the spring. Okay, spring yang berbeza, dia ada nilai K yang berbeza. Okay, so we have this. And as I told you before, okay, graph bagi force versus elongation sama bentuk dengan graph stress strain, kan? Dan yang saya ambil kira juga sama, iaitu dari point O hingga limit of proportionality. Okay, so we have this point here. So if you find area for this graph, okay, macam mana saya kira luas di bawah graf ini, sama juga area for the triangle, right? Maksudnya half darab dengan base kita strain in this case, darab dengan tapak, darab dengan tinggi kan. Tinggi kita stress. Sebenarnya half stress strain apa ini? Ini, okay, apa yang kita belajar tadi, ini sebenarnya adalah strain energy per volume. So this one is what you get. Okay? So can we find, if I find gradient, apa yang you dapat? Okay? Ingat, kalau saya guna nilai stress bahagi dengan nilai strain. Okay, so remember, kalau saya guna nilai stress bahagi nilai strain, okay, what do I get here for information? I will get Young modulus, the value for the Young modulus, remember? Okay, jadi you kena bezakan dua graf ini, dan juga kalau you cari area, okay, from this graph what do you get? You should know strain energy per volume, which is benda yang berbeza. Okay, kalau saya cari gradient dari graf ini, saya dapat Young modulus, but from here I get spring constant. Okay, jadi konsep tentang chapter ini itu je. Alright.